So here we have a video for the day I'm out, in case there's something you need help with in MYOPENMATH. And the first couple of questions are about domain and range, because you need that. Domain is going to be your x values, and your range is your y values. Some of you hardheads still haven't figured that out. But this graph is running forever left. So x is running left forever. And it runs right until it hits an x value of 5. Bracket on a 5. And by the way, if you're using a laptop, if you'll look down at the keys, you'll see brackets. You won't see the infinity symbol, but you'll see, the minus for negative and stuff. Use that. The range, this one is falling forever. So its low y value is negative infinity. And it rises until a hard y value of 2. All right, then we got a little bitty piece of a graph here. Its domain, it starts when x is 2, it stops when x is close to 5. And 2 is a solid dot, 5 is an open dot, so parentheses, that is a parenthesis. Its range, we have a low y value of negative 2, solid again. And we rise to a high y value of 7. Got another piece graph here. Domain, we have a low x value really, really close to negative 5. And we have a hard x value at negative 1. Range is your y values. We get close to negative 7. And we have a high y value of 2. I know some of y'all are struggling with domain and range. You need to figure it out. So here we have a piecewise graph, and that's where it gets really, really rough. You'll notice we have this small number down here, and look at how MYOPENMATH wants you to do things. It's not correct. I think one of the comments in a previous thing that you did said the stupid computer won't read it correctly. So that's how you have to do it. Let's see, our domain, we are running from negative 5 to negative 3. Parentheses on both of those are open holes. And then we're unioning with negative 3 to 2. And that's literally the letter U, because some of y'all couldn't figure that out last time. Range, we have this little negative 5 down here. Oh, there's more, isn't there? Union with, sorry, I forgot about this guy, 3 to 4. Forgot about that little guy. Bracket on the 3 because it's solid, just like I did a bracket on the 2 because it was solid. Range, we have this little bitty guy down here where y is negative 5, and you have to do as the computer says, negative 5, comma, negative 5. That is not correct. That's not how we write on paper. It's just the way the stupid computer wants you to do it. And we start with low y values, okay? Then we make this jump to where y is negative 2, and we rise to negative 6, and we'd be tempted to say we stop, but this graph takes over all the way to 9. So we jump to where y is negative 2, parentheses because it's open, and we jump until we have a y value close to 9. And I know that some kids don't get that, and we just keep throwing it at you until maybe you do. All right, consider the piecewise function shown below. You're supposed to plug some numbers in. You just have to feed it in the right spot. This says x is negative 1. Some of y'all don't understand function notation. You need to work on that. That has to go in the first equation. So negative 5 times negative 1 is 5, plus 4 is 9. 0 has to go in the second equation. It takes things greater than or equal to 0. So that would be negative 5 times a 0, add an 8, which is just 8. And 2 also has to go in the second equation. Negative 5 times 2, add an 8, and that returns negative 2. It's really easy stuff. Here we have another one of these. It's just a bigger piecewise function. Like, where can I feed a 3? I can feed a 3 here, because this thing takes x's between negative 4 and 4. So I have negative because I'm looking at this equation. 3 squared minus 5 3's add a 1. That's going to be -9. By all means, push buttons if you need to. Minus 15, add a 1 back. And then I just combine like terms. I add the numbers. It's -23. My brain's working right. 4 is also thrown in the same equation because it takes things between -4 and 4. Inclusive. So we have a negative, a 4, notice the use of parentheses. Some of y'all don't use parentheses. You're supposed to use parentheses. That's going to be a -16 minus a 20. Add 1 back, which should be -35. All right, the next one is m of -7, which has to go in this equation because it takes things that are less than -4. So this is going to be -7 minus 3, which is -10. We have m of -4, which again is that guy right there. It has a negative symbol. Then you encounter the x, and the x here is -4. Now, when you square a negative, you get a positive, but there's already a negative out front. We don't distribute the negative inside the parentheses because it has an exponent. Here we get to distribute the negative. And we end up with 5. M of 7 is going to be the last equation. It takes things bigger than 4. That's going to be -14 plus 3, which is -11. So question 4 is no big deal. Question 5, you're supposed to give the domain, and I don't know whether yours looks like this or not. Yours probably does not. Sometimes you might get lucky. And you do this from left to right, because this is where y is -5. And they want the domain using inequality notation. All right? So x is stuck between -6 and -3, inclusive. So we have to use the equality for including. Second piece where y is 5 up here. X is stuck between -3 and 1, and we get to include the 1 because of solidity, but we don't include the -3. And the last piece, I see that x is stuck between 1 and 5. I include the 5, but I don't include the 1. It's really not so bad so far. Piecewise graphing is coming, but it's not so bad. I skipped over a couple there. I think they were the same thing. I'm going to pull up MYOPENMATH. This might be where piecewise comes in. And I'm going to steal one of theirs. The reason I'm doing that is so I can show you how to actually graph on MYOPENMATH, because it's it bothers some kids when they actually have to do the graphing. Yeah, question 6 was a piecewise graph. So what I'm going to do on question 6 is I'm going to work it out so I can show you like my tables and stuff, and then we'll go back and we'll draw it. Because it's the drawing that bothers some kids. Graph the piecewise function shown below using lines, segments, rays, open circles, and closed dots, then determine its domain and range. Now, you're supposed to know what things look like. You know that -2x minus 6, and I mean that. You know, and the sad part is some of you don't. But it's going to look something like that. You know y equals -4 is something like this. And again, you know y equals x minus 4 is something like that. You're supposed to know these things. It's not my fault you don't. It really isn't. Anywho, let's do the first one. It says it takes things that are -4 or less. So you could take -4 and -5. If you feed it a -4, you'll get 8 minus 6, which is 2. If you feed it a -5, you'll get 10 minus 6, which is 4. So -4, 2 is a point that exists on the grid, as is -5, 4. And it's drawing left, it's less than, and it's an array that continues on forever. All right, -4 is valid between, y being -4 is valid between x values of -3 and 1. And I have an open circle at -3 and a closed circle at 1. Looks like that. And then we have the last one, which is x minus 4. We're going to feed it a 4 and a 5 because I can take things bigger than 4. If I feed it a 4, I get a 0. And if I feed it a 5, I get a 1. 4, 0 is open because of the symbolism. 5, 1 is closed. And then we're just going to continue on like that forever. It's actually easier to do it on paper than it is in a computer, because in the computer you got to press just the right buttons to do it. That's kind of the bummer. And some kids struggle with this. All right, so this guy right here is supposed to be array because it draws forever left. And I don't even remember. So that array is this choice right here. That's your array. I had -4, 2 and -5, 4. All right, solid dot there. I'll put that solid dot in. What else did we have here? We had -4 from -3 to 1, so we have to use the line segment. We have an open dot here where x is -3. We have a closed dot where x is 1. And then we had the last piece, which is array. It says x is bigger than 4. It's going to go to the right forever. And I believe the points were 4, 0, and 5, 1. Yeah, they were 4, 0, and 5, 1. Going to have to use array, 4, 0, 5, 1. And we have an open dot here. All right, now the rest of this is domain and range, is piecewise function. This thing comes in on the left from -infinity, and I'm using my keyboard, although you do have to use the button there for -infinity. It runs to 4 with a hard bracket. There's a letter U for union. Union with -3 to 1, parentheses on the -3, bracket on the 1. And then we have another U, union with 4 to infinity. Parentheses on the 4 because we have the open hole. And then the infinity symbol, also with parentheses. You can just check my answer here real quick because I have the key. Looks like I typed it in right. Range, we have this, and notice what talks about the idiot computer will mark correct things wrong, and you will need to ask your beloved math teacher for credit. I'm not giving you credit. You're going to type it in the way it says to do it, or you're going to miss it. Okay, I don't have that kind of time in my life. Anyways, the lowest y value is right here at -4, and you have to put it in twice. Then we jump up to a y value of 0, and we rise for infinity. So this tail right here goes from 0 to infinity. It doesn't matter if this tail goes from 2 to infinity because 2 to infinity is covered in 0 to infinity. So union with 0, comma, infinity. And let's just make sure I'm right because it's morning. Yeah, so perfecto. All right. There's questions. We're not going to do 7. 7 is just like 6. So I'm ready to go back to the notes I took. This is just basic algebra 1 simplification. You're supposed to eliminate the parentheses. Do not cheat. Do not cheat. Shame on you if you do. 2w times negative 2w squared is negative 4w cubed. 2w times negative 4w is negative 8w squared, because w times w is going to be w squared. Negative 5 times 4w squared is negative 20w squared. Negative 5 times negative 3w plus 15w. And negative 5 times negative 1 is positive 5. And then I combine like terms. So the biggest thing here when we talk about standard form is the negative 4w cubed. It is going to be followed by, if you put these together, negative 28w squared. And then plus 15w plus 5. It's not a hard thing to do. More of it. 3 times 4 is 12. W squared times w squared is w to the 4th. 3 times a negative 2 is negative 6. W squared times w is w cubed. 3w squared times 1 is plus 3w squared. Negative 5w times 2w squared would be negative 10w cubed, because negative 10 and w times w squared. A negative times a negative shall be positive. 5 times 4 has always been 20. W times w is w squared. And combine like forms, biggest exponent first. The biggest exponent is 12w to the 4th. There is such a thing called standard form. Then I see these w cubes. If I put those together, there's a negative 16 of them. Gone, gone. Then I got a 3w squared and a 20w squared, so plus 23w squared. Next thing should be factoring. If you watch the videos they do some weird, they do the X method of factoring, which I'm familiar with. I just don't like it. But that's me. I know, because I know how to double distribute, that it takes a W and a W to create a W squared. See the W squared? I know factors of 16. You may not, but they are 4 and 4, 1 and 16, and 2 and 8. And the goal is to add to negative 8. Only 4 and 4 are going to do that. Minus 4, minus 4. And this works because that makes positive 16 whenever you do that. And negative 4w minus 4w is negative 8w. It ain't hard. This one, I'll teach a pattern in chapter 2, but this is w squared plus no w minus 25. And I know it takes a w and a w. And I know that these factors are 5 and 5 or 1 and 25. And I know that 5 minus 5 is 0. Easy peasy, Japanesey. When I move on to the third one, this is also another difference of two squares. It takes a 5w and a 5w to create 25w squared. And when you talk about 36, by the way, remember that this is 25w squared plus no w minus 36. You can be like 1 and 36, you can be 3 and 12, you can be 6 and 6, you can be 2 and 18. Those are your factors, but 6 minus 6 is a 0. So one of them's positive, one of them's negative. It ain't that hard. It's not rocket science. It's knowing multiples. All right, last one. I'm looking at it and seeing if there's anything special about it. Sometimes you can pull a number, but there's not. This one might be a little harder, but I don't think it's going to be bad. Takes a 5w and a 5w to create your 25w squared. And I believe 6 and 6 is where it's at, because the outside's going to make 30w, the inside's going to make 30w, and if you add those things together, 30 and 30 makes 60. So easy peasy, Japanesey, lemon squeezy. It seems like the rest of these notes, I decided I would just pull some examples from MYOPENMATH. So let's take a look at this one. This is 11. You're supposed to use transformations. remember, what's inside is opposite. This is a left 4, up 3, and that's absolute value, which is a stinking V. We have to go left 4, up 3. Now, the initial slope is negative 1/2. That doesn't mean that well, actually, with absolute value, it doesn't matter. But you're only allowed to fall half a block as you run 1. And let's just check it. Did I get question? Ah, I got it right. I know what I'm doing. You can trust me. All right, here we have the square root function. I don't know why it's drawn. Oh, the mom is drawn. Graph x plus 4, square root of x plus 4 plus 3. This would be a left 4 up 3. Put me a point there. And the initial slope is this understood 1 in front. So rise 1, run 1. Pretty easy, right? Now you have to decide what this looks like. Which one of these is x squared? It's going to be that guy right there. Right 5, down 5. Opposite, trust. Be about right there. The slope is 3/2. That means that I can rise 3.5 units as I run 1 block. That's going to get some of y'all. Some of y'all are going to do rise 3, run 2, and it's not in the same spot. It's 1 block left or right that you get to do it. Let's see if Milbrath is right. He is right. Who would have thought Milbrath would be right? We have another square root function. Left 1, down 3. It is the square root function. That's the arm. Left 1, fall 3. And I get to rise 3 blocks and run 1. Am I right? Well, I'll be. Who'd have thunk it? Don't miss that question. That's absolute value, you idiot. Come on. Now write the equation. I know it's absolute value. If you look closely, you'll see you have an initial slope of 1. 1s are understood. So just absolute value. We went left, which is addition. We went left 1. So we have to add inside. And we also went up 1. Did I get it right? I did get it right. Go me. We have another writing equation. I'm not going to do that with you. There's a video. You figure that out. That one has a video. 18 does not have a video. This is a square root function. It's the arm. This one has an initial slope of 1. So just the square root. We have shifted left 4, which means we add 4 inside. And we have shifted up 2, so add 2 on the outside. Then I'm right on that one. And that is the MYOPENMATH video if you needed it. It was not a requirement that you watch this video.